Welcome back, my people. So a quick little update. It's getting a little dark on my end. Yes, I'm doing this after school on an A day, so if you guys can see, it's a little darker now here, and I had to turn on my lamp, but I still have my Diet Coke. All right, my people, let's get going. So this one is on thinking. This is Unit 5, Part 1, Module 34 and 35, and then Module 36 will be the last video. Okay, so this is Module 34 and 35, and then language will be Module 36. So let's talk about thinking and cognition and how it kind of all goes together, right? So when we think about lenses, so Unit 4, our classical and operant conditioning chapter, was all through our behavioralist lens, right? Now we're looking at this all through our memory, and this Unit 5, is all of our cognitive lens. This is about how our mind gets to A, gets to B, gets to C, right? So we are cognitive psychologists during this unit. So cognition is the mental activities associated with acquiring, retaining, and using knowledge, often directed towards a goal, a purpose, a conclusion. Thinking is the cognitive psychologist's study of how we use mental images, create concepts, solve problems, and make decisions and form judgments. So again, cognition is all about how our mind gets to A, gets to B, gets to C. And within this chapter, we're going to understand how we've learned about how we acquire information in our brains and how it's encoded, right? But how do we use this knowledge that we've all kind of, acclimated to? Like how did we, what do we do with all the knowledge now, right? Building blocks of thought, we have mental images and mental representations of objects or events that are not physically present. We are able to think abstractly, right? And we don't have to be, so if I'm thinking about going to bodega, right? I know it's going to take me about 45 minutes to get there from where I'm at. These are all mental images that we have within our brain, right? We know that, if we want to go to SF it'll take about an hour or, this or that, but we have mental images within our building blocks of thought. And we also have, within those images, we have concepts. Concepts are mental groupings of similar objects, events, ideas, or people. So, for example, we love to group together school stuff, right? So notebooks, pencils, school attire, or concepts of sports. So you might have all your sports stuff like all put together in your brain, right? And so we create these groupings to enable us to store more information. Concepts provide a kind of a mental shorthand or a shortcut to our cognitive efforts. So instead of, thinking of like, oh, what other types of fish, like what kind of pets can you have and how, like, I don't know how to think of it. It's a way to shortcut, like when we think of dog, our concept maps know that it's a pet we can have in the house, easy maintenance, well, for the most part, right? But we have these concept maps to help us. It's almost like Google searching for quick answers, but our brain has it because of these concept maps, okay? And so, for example, within these concept maps, we have prototypes. And prototypes are a mental image of a best example of a category. Pizza and fish are usually two different prototypes, right? Let's not get into the whole anchovy debate, but usually they're different prototypes. They're different groupings, right? So kind of a way to think about how we organize our thinking in a little bit more of a structured way. So we have concepts, which is our mental groupings of similar objects, just like we talked about. Again, we talked about our chairs and how there's like a couple, like we all know we have all different types of chairs we can sit in. We have the office chair. We have the chairs that you can like sit on the ball to like stabilize your abs, right? There's different types, right? But they're different. They're part of the same concept web in the prototype, right? We then have schemas, and schemas are the list of features of a concept. So the characteristics that make the item what it is. So for example, a chair is a seat, a back, it has a leg, it has a base. So schemas are more details within the concept, right? So for example, you can have a schema of what makes a house pet, right? So for example, house pets like bunnies, dogs, cats may be in a different schema than horses and elephants and, animals that don't fit into that details of those categories, right? And then we have a prototype. So like I just said before, this is kind of the way you think of it. So it's like layers. We have our concepts, and then within concepts, we have our schemas. which makes it a very detailed aspect of those concepts. And then within the schemas, we have prototypes. And these are the typical best example of the concept. For example, for me, I have like a bunch, I can have a schema for pizzas and, and then I can have, so I can think of like, so a concept could be pizza, and my schema for pizza is all the stuff we can have on a pizza. But my prototype would probably be like, oh, my prototype of a pizza is Hawaiian pizza, since that's my favorite. I love pineapple on my pizza. I don't know if it's a debatable thing, but I like it. I'm just saying. And so here's an example of how we can break it out again. So we have police officer, concept, police officer. Looking further in, a list of characteristics of a police officer, okay? And then we create a prototype. What is your best example or mental representation? And it could be this. Does your prototype match this female officer? Probably not. Sometimes our concepts can hinder our problem solving. We make judgments about others and situations. A lot of people's prototypes of police officers might automatically go to male. Again, these are all ways that we tend to organize, but they can also hinder us because they create biases in our own concept webs, right? So now we're going to talk about different ways that we can problem solve. And problem solving is when we manipulate mental images and use concepts, including prototypes and examples, of when we need to solve problems. And the biggest one we use, especially from the age of birth to probably like elementary school, is trial and error, right? This is the best, simplest way to problem solve, is trying different solutions and eliminating those that don't work, right? So think of a time as a child where you had a problem to solve by trial and error. And this is when I would usually have you guys all share your funny stories of, wow, like running full speed into something that shouldn't be ran into hurt, or, I don't know, like things that we learn, like falling off a couch hurts, so maybe we shouldn't do it, right? And it's just, that's how we learn in the first parts of life, is trial and error. So let's go a little bit further in. So once we become more developed as a human being, right? So here are some more advanced problem solving. We had trial and error. That's the basis, right? That's the main one. But there are other 3 ways to solve problems. We have algorithms. These are methodical, logical rules or procedures that guarantee solving a problem. So for example, algorithms are like a formula that always gives you the right answer. If you want to know the slope of something, y equals mx plus b, my people. Why do I know this now? I don't know, but here it is in my this is what I thought of. So we use algorithms to get the exact answer. So algorithms for problem solving are the best. They are the most secure with the correct answer, right? So if we plug this into an algorithm, into this formula, we're going to get this, right? Another way we can solve problems is heuristics. And I want you to put in your notes, heuristics are like shortcuts. These are simple thinking strategies that often allow us to make judgments and solve problems efficiently. I would like you to Google it under heuristic. Heuristics are great for fast knowledge, but they're not always right? So algorithms, super correct, right? Because you're using formulas. Think of Google. If you type stuff into Google, you never know what you're going to get, right? But it's a quicker way of studying, right? Or a quicker way of getting an answer. And then we have insight. And this is like the least reliable. So if you want to think of algorithms, most reliable, heuristics in the middle, and then we have insight, which is kind of like our gut intuition. So it involves a sudden novel realization of a solution of a problem based on prior experience. It could be initial trial and error to gain insight. But remember, insight is the least structured of these 3 problem solving strategies, okay? So we have algorithms, which is an exact answer, heuristic, which allows us for a shortcut answer, but may not always be true or correct. And then we have insight, which is essentially going with your gut, right? And then thinking, I solved this problem, but a lot of it is up to chance and it's not always the most reliable, right? So that's problem solving. And then I would have us do this as a class. So I am going to, okay. I'll explain it in class too, but I usually have you guys try to solve this problem, which is, the problem here is to use only the objects pictured to mount the candle on the wall. And then I would have you guys try to problem solve, figure it out, and you would usually hit these couple roadblocks. So we have fixation. And these are obstacles to problem solving. These things could affect your problem solving. Fixation is our inability to see a problem from a new perspective. We're fixated that this is the only way it can happen. And that is an obstacle for our problem solving, right? If we're not able to see it in a different light, it restricts us, right? We also have a mental set, and mental sets are the tendency to approach a problem with a mindset that has worked in the past. So a mental set. So if you've done this in the past, you're going to try to do the same way as last time, right? Even if it's not the best way. Again, an obstacle. We're set in the ways of what we know works, right? But also, we have this thing called functional fixedness, which is the tendency to think of things only in the terms of their usual use, which is where this comes in. So for example, people who, the only thing to use a soda can for is to drink soda. Some people may not think that, oh, this is perfect for if you make bacon, you can pour the grease into this can. It can be a grease trap, right? So that is an ability to use something that's something other than its original use, okay? Now that I have it in my hand, I have to take a sip. Okay, so now that I have my stimulant, we can move on. So again, these are all three ways of obstacles of problem solving, okay? So how are these different? So these are some other ways that can create a bias with our problem solving. So we have confirmation bias. This term shows up in a couple of chapters, and it's when you are seeking evidence and you only see evidence that supports your bias. You ignore evidence that goes against your claim. So it's kind of like looking for articles that say the sky is purple, and then you're going to ignore all other evidence of like the sky is blue, but you're only confirming your bias. Does that make sense? So confirmation bias, you're only looking for things that go with your viewpoint, right? And then we have belief bias, where your belief alters the way you make a conclusion, either accepting illogical conclusions because it matches your belief, or rejecting logical conclusions because it contradicts your belief. So if my belief is that, I don't know, the world is going to end in 5 years, right? I don't know, guys. This is just very random. I am not going to accept anyone else's. Like if people tell me, oh, you're wrong, it's gonna be 20, I'm going to reject any logical conclusion that contradicts my belief. Okay, I'm not gonna do it. I'm like not gonna have my beliefs challenged. And then there's belief perseverance. This is when contradicting evidence is obvious. So say that I wrote a whole paper about how the sky is pink, right? And all this evidence comes out saying the sky is blue and it got debunked, and I still believe it. That is belief perseverance. I believe something even after it's been debunked, right? So it's kind of like Freud, who's like, I believe in this and this. And everyone's like, oh, Freud, maybe you shouldn't, right? Even though it's been discredited, a few of the things, right? But your beliefs persevere, right? Again, we are our own human bias. We can't help it. We just can't help it. Okay. So some really cool things about problem solving, decision judgments, and additional influences. There is intuition. Coming to an effortless conclusion or making a judgment without conscious awareness of the thought process. So, for example, these people who breed chicks can tell if a chick is a boy or a girl from the very early stages of being a baby, when usually people can't tell, but they use their intuition to decide, which is, I know, it's crazy, my people. But our intuition, it's there, but it has a lot of flaws, right? Because not always, our gut feeling's not always right? It enables us to have quick reactions, which have been found to be based on unconscious perceptions, based on expertise. Our intuition, it's when the feeling, it's essentially it's when amounting to the overfeeling and underthinking can be based on our gut fears or prejudice. So our intuition is bias because of our perceptions, right? So again, intuition is not like an algorithm which gives you an exact answer, right? Intuition is almost the least reliable, but It works sometimes, right? It doesn't work all the time, but it works sometimes. Look at this nice juicy burger. I know you're like, Miss H, why is this on my screen? But real quick, I want to talk about framing effects real quick before we finish up our little video. But framing effects is how an issue is presented or framed can significantly affect the process, the judgment, and the decision of the people who are buying the products. For example, which sounds better? Ground beef that is 75% lean or ground beef that has 25% fat, right? So again, it changes your perceptions in the whatever you choose at the grocery store just by the framing effects, right? So how is framing different than priming? Framing is how you present the information or ask a question itself or alter the response. And priming is when you present a stimulus that alters the way they respond to the information that comes after the stimulus, okay? So that is it for this video. We have one more video. You guys are almost done. You got this. And I will let you guys finish up this video.